Okay, so we continue with one more example regarding the calculation of the cross product of two vectors. Suppose U is the following vector, 2i plus 3k, and V is the following vector, I minus j plus k. Or if I wanted to give it into the other notation, 2i plus 3k would have been the vector 2, 0, 3, because we don't see j, meaning that its coefficient is 0. And the coefficients here are 1, minus 1, and 1. So we have two parts. Part 1, I want to find U cross V. And suppose we want to show it in this notation. So please try this on your own before watching my solution. So again, using that determinant way to find the cross product, I, j, k go to the first row. U is on the first vector in the product, so I write the coordinates of U 2, 0, 3, and then V consisting of 1, minus 1, and 1. So some coefficient time I minus some coefficient j and plus some coefficient k. That's how we expand the determinant. For the I ignored the row and the column that I is located on and find the determinant of these 2 by 2 matrix, 0 times 1 minus 3 times minus 1. So 0 times 1 minus 3 times minus 1, which is 3. For j, for the coefficient of minus parentheses j, that's missing coefficient, we forget about the row and the column that j is located on. 2 times 1 minus 3 times 1 is negative 1. And finally, for the last coefficient, I ignore the row and the column that k is located on. 2 times minus 1 minus 0 times 1, so which is negative 2. So the three vectors, 3 minus minus 1 is 1, and negative 2. In part 2 of this example, I want to find the length of U cross V. We already found what is U cross V, so it's easy to find the length of that. So it's going to be the length of the result of U cross V's the vector 3, 1, negative 2, and the length of this vector is radical of 3 squared plus 1 squared plus minus 2 squared, which gives us a radical 14. Speaking of the length of the U cross V, There is another way that we can obtain U cross V. It can be proved that if we have two vectors, suppose I draw them in a way that they have the same initial point. So these two vectors, and if they make an angle of theta, the length of U cross V, just the length, not the vector U cross V, just the length of U cross V. It can be proved that it is equal to the length of U times the length of V times the sine of the angle they make, sine of theta. But this is helpful if we know the angle of the two vectors. Like in this example that we didn't know what the angle these two are making, the best way to find the length of U cross V was by this method, because we didn't know that at this point that the angle was not given. Of course, we can use the lesson that we did for the dot product, and we can find the angle, and after finding the angle, use the formula here to find the length of U cross V. But this method is a little bit shorter to find U cross V, the length of U cross V. So here is one formula, and it's very helpful if we know the length of U and V and the theta, the angle between these two are given. So for example, if length of U is given to be 5, length of V given to be 4, and the angle between them is given to be I/6 or 30 degrees. So let's have this information. Find the length of U cross V. So that's an easy question. If you want, you can pause the video and do it on your own. So to do that, that's going to be by using the formula that you see on the top. Length of U times length of V times sine of the angle. In this example, length of U was 5 times 4. Sine of theta, sine of pi/6 is 1/2. So 5 times 4 times 1/2, which gives us 10. So with this information, I can only find the length of U cross V. I cannot find U cross V just by the information we see in this example. But I can find the length of that. In this regard, we know that this formula is something more familiar in geometry, that in a parallelogram, you know that in a parallelogram like this, suppose the length of this side is L1, this side is L2, and the angle they make is theta. The area of this parallelogram is going to be L1 times L2 times sine of theta. So if I want to translate this into vectors, it means that if a parallelogram, let me write a note for the vectors, which is related to what we have talked about, cross product. Let U and V be two adjacent sides of a parallelogram. Let me give the coordinates of u and v. So suppose u is the vector 1, 0, 1, and v is the vector 1, 2, -1. So these two vectors are two adjacent sides of the parallelogram. Find the area of the parallelogram. Excuse me. So instead of using this formula, one way is instead of using L1 times L2 times sine of theta is not given here. As I said, using the dot product, I can find the theta, and then after that, I should find sine of theta. But even without before this formula, I know that this formula is equivalent to finding the length of U1 cross, I'm sorry, U cross V, the length of U cross V. So to find that, I can find, to find this area, I can find the length of U cross V. This will be the same as this length of U times length of V times sine of theta, and that will give out the area of the parallelogram. To do this, I can find U cross V using the way that we did for finding the cross product of two matrices, and then find the length of that. So on the next page, I'll find first U cross V, because U and V are given. One, 0, 1. I'm using the very same information from here. So V is 1, 2, -1. So U cross V, I form this determinant ijk 1, 0, 1, 1, 2, -1. So this is the expansion of that determinant for the coefficient of I. Forget about this row and this column. 0 times -1, -1 times 2, which is -2. For the coefficient of J, I disregard the first row and the second column and find the determinant of the rest. 1 times -1, -1 times 1. It's going to be -2. For the last coefficient, I ignore the row and the column that K is located. 1 times 2 minus 0 times 1, which gives me 2. So the vector of U cross V is -2 plus 2 and 2. So the length of U cross V, which gives me the area of the parallelogram, is gonna be the length of this vector, the length of -2 2 and 2. Radical of -2 squared is 4, 2 squared 4, 2 squared 4. Radical 12. As you know from basic algebra, we want to simplify these. 12 is 3 times 4. 3 stays under the radical, and radical 4 is 2. So it is 2 radical 3. So that's the answer. That's the area of this parallelogram that we are talking about. For clarification, let me write a note. Okay, so based on this example, let me write a note regarding the area of a parallelogram when the two adjacent sides are given as two vectors. So let U and V, these two vectors, be two adjacent sides of a parallelogram. Then the area of the parallelogram is the length of U cross V. So if I find U cross V and then find the length, that length gives me the area of the parallelogram. That's exactly what we did in this example. In this example, the two vectors were given and they were the two adjacent sides of a parallelogram. The area, for finding the area, we found U cross V, which happened to be the vector -2, 2, 2. And then the length of that vector, which was radical 12 and simplified as 2 radical 3, that 2 radical 3 is the area of the parallelogram. In general, this is true.